Okay, good evening, everyone. So today we will be having a short introduction to Docker, how exactly to do the installation for Docker, and run a couple of Docker commands as such. All right. So last time we had a small session on how to create VirtualBox, how exactly to log into VirtualBox, and all of this. So using that very same VirtualBox, I have logged into that particular system. Now, it is not necessary that you have to install Docker only on VirtualBox or on your Ubuntu box or on Linux box. You can install Docker absolutely anywhere. So you can install it in what do you say? You can install it on Windows. You can install it on Ubuntu. You can install it basically anywhere. So that being said, okay, let's go ahead and start with the installation of Docker on this particular Ubuntu machine, which I already have. Okay, could you please mute yourselves, everyone? Okay, so Docker command is not found. So I'll start with an apt-get update. Just a moment, everyone. Okay, so the update is complete. Now let's go ahead with installing Docker. Okay, so you have to do sudo apt get install docker-ce. Okay, it says that there is no docker.ce available, so it's probably sudo apt get install docker.io. Yeah, so that's the one which is available. Okay, so that shows that your Docker has been no, sorry, your Docker is now pretty much installed. We can just check for whether Docker has been installed. It says so Docker version so and so. Okay, it says that it's been installed. There are a couple of permission denied errors. Let's do this. Docker version, and it says everything is installed properly as such from this particular perspective. Now let's start off with a couple of simple things to do with Docker. So what do we start off with? So I have like a small cheat sheet which I created for myself as in to aid with this particular what do you say session. So let's go ahead with that and check it out. Okay, so let's do this. This is the one. So I will just close this. You don't have to have this. This is so that I can aid you all with the cheat sheet as such. Now, let's start with a couple of simple commands. So there is this particular thing. Now, let's give a little bit of a background. So Docker is basically something which is what do you say, a container-based system. It is similar to a virtual box in certain ways, but it is much more lightweight as such. So there is something known as the Docker engine, which takes care of everything as would a virtual box hypervisor does as such. Now that being said, what it would do is over here, now once we start creating Docker containers, it would create like these small boxes, small containers, which are isolated containers in themselves, and they allow you to, what do you say, run these isolated environments for Python, so for Ubuntu, for CentOS, anything as such. Now what we are essentially trying to do is we are trying to run a Docker container within this Ubuntu box which we already have. You can also do it on your local desktop. It does not really matter in that case. So let's just do this. So Docker sudo, we need to use sudo in this case because it is not owned by the local user. It's owned by the root user. When I do sudo do docker ps minus a, what it gives is all the Docker images currently, or all the Docker containers currently running, which basically it means that there is no Docker image currently running. Now let's start with a simple one: sudo docker run hello. Okay, so what it would do is, you'll see, it tells you, unable to find this hello latest locally. It says so and so repository does not exist or may require Docker login. Now I'll talk about Docker login later. Okay, now what it says is it's unable to find any particular image. So let's see if we can find something which can possibly be available. Let's try this: sudo docker run ubuntu. Okay, so it will probably pull the latest. Yeah, so it pulls this particular image. So what it does is, just like you have an ISO image, you have this image for Docker containers as well. Okay, these are the container images, and these are pulled from Docker Hub as such, which where what basically it means is Docker Hub is like a repository, just like GitHub, only here it is these are images which are stored on for Docker purposes as such. Okay, we won't go into the details right now, we'll just go from the top as such. Now what has happened is, I pulled this image. Okay, when I did a run over here, because it couldn't find an image locally, it it went ahead and searched Docker Hub, and it pulled this from the Docker Hub as such, and it set the image over here, in this particular Ubuntu system as such. Once it did that, it went ahead and started running it. Now, just to check whether it's actually running, let's try to do this. Sudo docker ps minus a. PS basically stops at being, it says basically sudo docker ps. PS would mean that show all running images. Minus a shows all the images. But what it says is, this image which I pulled in, okay, it kind of exited, it crashed. So we could do another command to see why exactly it crashed. You could do this: sudo docker logs, and I take this container ID. Okay, you've got the image, you've got the command which was run, so and so. We've got the container ID. Okay, it doesn't throw up anything majorly because there was nothing really that had actually run. Now, because of that, what happens is that, what do you say, we are left with the stale image. We don't know what exactly happened, we don't know what exactly ran, nothing at all. So what I'm going to do is, because there's a stale container here, now remember, it's best not to leave stale containers as they are. It's better to remove them. So for that case, I will do sudo docker rm copy and paste. Okay, and let's see again, sudo docker ps minus a, and it is gone. It's no longer there. But also remember that when I do the sudo docker, whatever it might be, so sudo docker run, sudo docker pull, or whatever it might be, so when I run this sudo docker run ubuntu command, it internally also ran this command, sudo docker pull ubuntu. which means it pulled that particular image. So if it pulled that image, that means it should be available somewhere here. So I can do this command, sudo docker images, just to check. So when I did that, it says it found an image called Ubuntu over here. Okay, Ubuntu latest, blah, blah, blah. So sudo docker images. So I can do this. Kill, no, not kill, sorry. To remove this image, I can use this command. Because you see that, this image has occupied a space of roughly around 73.9 MB on my disk. Okay, and I don't really want that to occupy. Sometimes it does happen that you do not want that particular thing to be occupying your disk as such. You do sudo docker rmi ubuntu, and it went ahead and deleted all those particular containers as such. Now, one thing you should remember is when you create or when you pull a container and then when you run the container, okay, it usually is created in layers. You'll see there are multiple layers created, 1, 2, 3, 4, 5, so and so layers, because you know the original base container would be a very lightweight system. There would be nothing on it at all, maybe just the bare minimals of the Ubuntu OS. On top of that, they put additional, what do you say, additional layers, so that it can allow for something more to happen. We'll not explore details of this, but I can show you how it actually goes through that, how it actually goes through that particular process. Okay, now you got a basic idea of what exactly happens here. Okay, so because it went ahead and did this, let's take a look at the commands which I already have. Okay, so there are various commands, sudo images, sudo inspect, so and so. What we will do, okay, right now. So we were able to pull an Ubuntu image, but essentially it did not do anything much. Let's see if we can do something else here. Sudo docker run, maybe Python. It might actually work. Sometimes it does happen that there is a package for Python. So let's see what actually happens. It pulls some image for library image. Okay, let's wait for it to complete. So it's going to take a little bit of time depending on how many layers are being downloaded. Because over here you see there are multiple layers. So one of the layers would be an OS. Okay, that would typically be usually Ubuntu in this case, and other layers with respect to Python and other installations which are required along with Python. So it does a download, it extracts, and then it completes the installation or whatever internally. So let's see what exactly happens here. Let's wait for a couple of seconds maybe, just to see to it that it is complete. So once this is done, what we will do is we'll see if we can log into that system and do anything with it. Okay. So docker ps minus a, sorry, sudo docker ps minus a in this case, and it says it exited so and so minutes ago. Okay, let's see if it manages to come up. It doesn't do anything. Sudo docker exec minus it crash. Yeah, so it's not running. So here you see that I have run a particular command. Okay, so basically what this command is supposed to do is, if this command is if this image is actually running, I would be able to log into it by doing this particular command. So it says execute in an interactive mode into this particular container using bash. okay, using the bash shell. So it could be bash shell, it could be C shell, whatever shell we might want. Some use, an sh shell depending on what they want. But in this case, since it is not R, you can't get into it. Now, with that being said, there's something which I have already tried out, which actually works. So we will try that out as such. So what we are going to do is we are going to create our own image. Okay, we are going to create our own image. So far we've been trying to pull images from, what do you say, images externally as such. So let's first get rid of this image. So docker rmi, that is remove image. No, sorry. Let's rm first remove this particular container. Docker images. So you see the size of this, it's 882 MB, close to a GB. Docker rmi, and I will use the image ID to remove this image, and it deletes that particular image. Now what we will do is we will create a particular image, okay, and we will also try to run a Flask app on that. Okay, let's go through the basics of that. So what are the things which I need for this particular thing, okay, to make sure this happens? The first thing which I need is something known as a Dockerfile with this exact same name, with a capital D, Dockerfile. Okay, for Flask, I need a Flask app. So I need basically a Python Flask app. So I've written a simple, very simple Flask app, the bare minimum. From Flask import Flask, app Flask name, app root, so and so. And I have this, what do you say, the base root returning, hey, we have Flask in a Docker container. And over here, I do an app run, debug true, host 000, which means I am able to access it from anywhere. Okay. But the only fancy part is it would be running inside a container. Along with that, along with this app.py, we need to have this thing called the requirements.txt file. Now, we've spoken about this earlier, where these requirements are really needed so that, our application is able to run as such. For example, in our requirements file, we basically need Flask, the Flask web framework as such. So, which is why we put Flask in the requirements file. Now, what goes into the Docker file? What is it that is needed? So let's go through these particular details. From ubuntu 16.04, okay, that means, your Docker file is going to use this particular image, which is available online, probably on Docker Hub, Ubuntu 16.04. 16.04 being, just like, we have our Ubuntu 20.04 running over here. This is an older version as such, just like that. Now, the maintainer, okay, maintainer is basically your name, blah, blah, blah. You don't need this. Maintainer so-and-so. So I put this experimenter of official@gmail.com, whoever is going to maintain this Docker file. Following that, you'll see that there is a run command. This run command is going to run some, Ubuntu commands on that particular Docker image, not on your local host, but within the Docker image when you start to do a Docker run. So apt-get update -y, install Python 3, Python 3 pip, Python 3 dev. These are the 4 packages which I will be installing as such over here. Okay, so -y basically says that it will consider for any particular prompt which comes up saying that do you want to install Python 3, it would automatically give a yes. Now, after that, we would need to copy the requirements.txt file to a particular location on the Docker container. Now, in this case, I have done it in the /app. Basically, your application, generally, you put it in a particular directory called /app when it comes to Docker. So you put it in /app/requirements. Okay. So you go with this particular, annotation, and then work dir. That means the work directory is going to be /app. That means whatever you're going to start with internally, okay, will be done from the /app directory as such. Okay. Now, once we are done with that, what is going to happen? We need to install the requirements. So run pip3 install -r requirements.txt, because it needs to run the requirements which are there within that particular requirement.txt file. So we need a Flask, so it will be running, because by default, Flask will not be running anywhere at all. So you would make sure that Flask web framework is installed using this command. Now, once you do that, copy dot /app. That means it copies everything over from my current directory over to /app. In this case, we had only copied requirements. In this case, I'm going to copy everything else, which means I will also be copied the app.py file into that particular thing. So everything that is in the current directory gets copied. Okay. Now, after that, we have this command called expose 5000. Now, why do we have expose 5000? Now, if you have gone through the Flask tutorial properly, you would realize that the default Flask app, it runs on the 5000 port. Okay, we have not changed the default behavior. So if you want, you can change the default behavior within the app.py to change it to be 8000, 8080, or whatever you want. But in this case, we'll leave it as it is. We will expose the port number 5000 so that it can listen on that port. And then we have got something known as an entry point. So entry point is basically Python 3. So this is the point where you enter this particular, what do you say, particular application, your particular container. So Python 3 is your entry point, and it runs the app.py file from that particular entry point. Python 3 app.py gets run. Now let's take a look at how exactly we accomplish this. We need to first create a Docker image. Okay. Once we create the Docker image, we would have to, what do you say, we have to build it. So first we need to do this. Okay, I will tell you what exactly this means. So here, what I run is this command: sudo docker space build, because I need to build that image, -t. This -t stands for tag. Okay, so what tag? I give this image which I am building a name called Flask Docker. You can change it to whatever you want. It depends on what is the name of the image that you want. So for example, if you have Ubuntu image, you put it as Ubuntu. Now what I want is specific to my application. It is a Flask web application on Docker. Okay. And then I give it followed by a colon, I give it a tag called latest. So it depends. So what happens is that we have versioning we can keep versioning in Docker. So what I do is I say my version could be 0.1. Latest basically means that it's going to be the latest version. It's the versioning style as such. So I'd say my version is 0.1, and I want to build it from the Docker file which is present in the current directory, which is why I simply give a dot. Okay, which is why I simply give a dot. Otherwise, you will have to give the exact directory where this particular Docker file exists or something like that. So in our case, we will simply do dot over here. Okay, and then it will start building this particular what do you say, image from scratch. You'll see it starts downloading a couple of things, the Ubuntu 16.04, etc. Okay, so it's downloaded it, and then it's run the maintainer, and now you'll see here it's running a couple of these commands, okay, automatically. So Python 3 is installing by itself, Python dev is installing by itself, pip is installing by itself. So that's all needed, that's all needed for our application. So let's wait on that and see what exactly happens. Okay. So it'll take a couple of seconds to complete the installation. It's almost done. And now it's going on to the next commands. So pip install, it's doing a pip install, collecting Flask requirements. You see the pip installation is going on for Flask. Okay. So once it went, it copied over everything. It exposed the port 5000, and you see successfully tagged Flask Docker 0.1. Okay. Just to check whether the image has been created, you can do sudo docker images, and you see there's an image called Flask Docker that has been created. It used the Ubuntu Docker image as a base, and it created this Flask Docker as such. Now let's go ahead and see what we can do with this. So as I told earlier, you can use that particular image and run it. So sudo docker, sorry, sudo docker. Now you want to run that particular image, that specific image. Sudo docker run -d -p 5000 for 5000 Flask Docker. So what does that mean? So it tells run this particular image in a daemon mode, as in, as a background process. Expose the port 5000, that is using the port 5000. -p stands for the port. So what it does is it forwards the port 5000 to our local environment. So 5000 from to 5000, so that we can use it from our local environment as well. You don't have to log into that system to do anything. So it forwards this because it's been exposed over here. Okay, it's been exposed over here. And you tell the name of that particular image, that is Flask Docker. So once we do that, let's hit enter. Unable to find image Flask Docker latest locally, it says denied. Now the reason being, we don't have latest, we only have 0.1. So we'll give it to the tag, and it ran it successfully. Now what do I do with this? So sudo docker ps-a, you see that this Python app is up for the past 9 seconds. The port has been exposed on the 5000 port has been exposed here and has been forwarded. Now, how can I confirm that everything is good? Does my application work as it's supposed to? So I can simply do what is known as a curl command, curl localhost 5000, because I had told the moment I hit the slash, what do you say, root, I'll be able to get a message. So it says, hey, we have a Flask in a Docker container like we had in the app.py file. And that is how you run a Docker file, what do you say, how you build and you run a particular Docker file as such. And in this example, we've seen how to create a Flask application within, a running Flask application within a Docker container as such. Now, with that being said, I think we are pretty much done with today's tutorial. Okay. I would have loved to show you, what exactly you can do with a Docker repository. For example, you need to go to, for that, you need to go to hub.docker.com. So you can make your image available, externally. So say I create an image, but you want to use it, you can make it, available externally. So for that, you probably have to register with hub.docker.com. Okay, once you register with that, it'll ask you for a couple of things, and then you go to create a repository. Okay, so once you create a repository, it will tell what exactly do I need to create. Okay, so you can create a repository by the name, say, Flask Docker, like I did earlier, using that particular image name. Okay, so let's see if I can do this as such. So it gives you a couple of additional things. So example, Flask application on Docker container, just a simple one. Okay, let's see what happens here. Okay, so here it went ahead and created this particular thing as such. Okay, so it says push a new tag to this repository, blah blah as such. So now Let's go ahead. So no tags available, no builds available, timelines, so and so. So we can push a particular tag. Let's see if we can pull this particular repository. Docker pull. Hold on a second. We need a sudo. Okay. It uses the default tag. So latest not found because it couldn't do anything with that as such. Okay. So for that, you would probably have to do a, what do you say, login, but that is probably for another day. So for today, we will stop with this particular example as such, with our Docker tutorial.